Unless you've been completely off the grid for the last few years, you've probably heard the rumors. Using the James Webb Space Telescope, the most advanced piece of machinery humans have ever put into the void, scientists detected something incredible on a mysterious planet called K2-18b. They found a potential biosignature, a molecule called dimethyl sulfide, or DMS for short. Why is that a big deal? Because here on Earth, DMS is produced in exactly one way, by living things, specifically marine phytoplankton. Finding it floating in the atmosphere of an alien world 124 light-years away means there is an excellent chance we just detected extraterrestrial life for the very first time. If this is true, it changes everything. It means the universe is teeming with life, and Earth is just one of billions of inhabited worlds. But as Carl Sagan famously said, extraordinary claims require extraordinary evidence. So, are the claims about K2-18b actually extraordinary? Have we finally found our cosmic neighbors, or is this just another massive scientific false alarm? Let's find out. To understand the hype, we have to look at the planet itself. K2-18b isn't exactly Earth 2.0. Discovered in 2015, it's a heavyweight, about 8.5 times the mass of Earth and more than twice as wide. It also orbits a red dwarf star. This star is only half the size of our Sun and produces a fraction of the energy, meaning K2-18b has to orbit incredibly close to stay warm. For a long time, astrobiologists ignored planets like this, but in 2019, the Hubble Space Telescope detected water vapor in K2-18b's atmosphere. Suddenly, this weird bulky planet became the first exoplanet in a habitable zone to actually have water. Naturally, NASA pointed the newly launched James Webb Space Telescope right at it. In 2023, JWST delivered. It found strong evidence of methane and carbon dioxide and just the faintest whiff of our magic ingredient, DMS. Initially, the DMS signal was incredibly weak, what scientists call a 2 sigma confidence level. In plain English, there was a 5% chance the telescope was just picking up random background noise. But a 2025 follow-up study changed the game. Project lead Niku Madhusudan and his team pushed that confidence level to 3 sigma, meaning there was now only a 0.3% chance it was a fluke. He called the detection astounding. The press went absolutely wild. But how do we even know what's in the sky 730 trillion miles away? We use a technique called transit spectroscopy. When a planet passes in front of its star, a tiny sliver of starlight filters through the planet's atmosphere. Different molecules in the atmosphere absorb different colors of light. By the time that light reaches our telescopes, it looks like a barcode with missing stripes. Read the barcode, find the missing stripes, and you know exactly what molecules are in the air. Simple, right? Wrong. It is ridiculous.
Interpreting that barcode isn't like scanning a box of cereal at the grocery store. Alien atmospheres are chaotic. They have weird clouds, extreme pressures, and temperatures we can barely comprehend. To read the spectrum accurately, scientists have to guess what the planet's climate is like. They use supercomputers to generate thousands of simulated atmospheres and then look for the one that best matches the telescope data. And right here is where the K2-18b hype hits a brick wall. The Cambridge team's blockbuster study relied on one massive assumption, that K2-18b is a Hycean world, a planet entirely covered in a massive ocean with a hydrogen-rich atmosphere. That could be true, but it's not the only option. Some scientists think K2-18b is actually a molten magma world. Others think it's a mini Neptune made of gas with no solid surface at all. If the planet is covered in lava instead of water, the barcode changes completely. In fact, shortly after the Cambridge study broke the internet, a physicist from Oxford University reanalyzed the exact same JWST data using a different model. Their conclusion? Zero evidence of DMS. The fact that two brilliant teams can look at the exact same data and get completely opposite answers tells you just how hard transit spectroscopy really is. But let's play devil's advocate. Let's pretend the Oxford team is wrong, the Cambridge team is right, and K2-18b is a beautiful ocean world swimming in DMS. Does that mean we found aliens? Nope. For decades, DMS was considered the ultimate silver bullet biosignature. If you found it, you found life. But the universe has a funny way of ruining our neat little categories. In 2024, scientists found DMS in a place it absolutely shouldn't be, the tail of a comet right here in our own solar system. A frozen, barren rock with no atmosphere, no ocean, and zero chance of biology. It turns out the universe has secret, non-biological ways of making DMS that we don't fully understand yet. So even if K2-18b is packed with the stuff, we still can't prove it was made by alien plankton.
So, where does that leave us? As much as it pains me to say it, the chances of life on K2-18b are slim. The DMS detection is built on fragile assumptions, and even if it's real, it's no longer a guarantee of life. But this isn't a failure. It's actually a massive win for science. K2-18b has a super tight orbit, meaning a year there lasts just 33 days. That gives JWST a chance to scan its atmosphere once a month. Transit spectroscopy is a brand new, rapidly evolving science. We are essentially watching humanity learn how to read the atmospheric barcodes of the universe in real time. K2-18b might be a false alarm, but it's the perfect practice target. Because one day, JWST, or a telescope even better, is going to point at a tiny dot in the sky, read the barcode, and find a signal that we simply cannot ignore. We just have to make sure we know how to read it when the time comes. Thanks for watching.